that an IoT system typically consists of a network made up of multiple nodes. Okay, nodes, NODE, or multiple devices. Okay, and obviously because there are multiple devices which are connected to each other, um the most fundamental building block in that case becomes the device or the node, which is there sitting in the field and taking all the measurements and doing some amount of computation and communicating the information back to the cloud or relaying it back to other nodes, right? So that is what smart objects are all about. Okay, but in literature or in internet, wherever you may look, you will find them being referred to by multiple names, right? So you may find them being referred to as the thing, internet of things, right? So thing is actually the smart object, or you may call it as smart thing, intelligent node, ubiquitous thing, smart device, smart sensor. All these are basically the same thing. We are referring to the same uh, unit of IoT in all these cases. Uh, Before the idea of Internet of Things became popular, we used to call the same thing as smart sensors. Okay, in instrumentation terminology, instrumentation engineers used to call this kind of devices as smart sensors. Then, as IoT became more popular, it became the thing in Internet of Things, right? And that's how we keep on going. And it's also referred to as node because that helps in understanding the topology wise. Computer science people call it node, instrumentation people call it smart sensor, proper IoT engineers call them as things, and so on. But basically, it's the same device. But what is actually a smart object? So this diagram that you're seeing on the right hand side is what a smart object is about. Okay, a typical smart object will have all these units. It will have a computing system built into it. It will have sensors and actuators to interact with the environment around it. It will typically have some kind of power supply built into it, and it will also have some communication device. Just give me a second. Right. So as I was saying, you can see there are four major parts of a smart object. You need to have some computing, you need to have a power supply, you need to have a communication device, and you also need some kind of a sensing and actuating mechanism built into it. So all this together form the smart object that we call the thing or the smallest unit of an IoT system. Okay, so let's go into each of them one by one. We'll initially start with the processing unit. Okay, so this is typically something which has the capacity to uh, read the data from the sensors, do some small processing, and maybe give controlling actions to the actuators which are existing on the thing, right? So typically you can imagine the computing unit or the processing unit to be a simple microcontroller, right? I'm assuming that some of you may have worked with some kind of microcontrollers before. Have you worked with any kind of Arduino or something like that? Can I see a show
Yes,
of hands? How many of you have worked with Arduino? Okay. Yeah, some of you have worked with Arduino. So if you remember, Arduinos can be used as small computing devices, right? But not all of them have good communication modules built into it. So you may have seen a version of that which is called the Node MCU. You heard of that Node MCU? Some of you have worked out.
Yes, sir.
Yes, sir.
Yeah. So how many of you know about Node MCU? Show of hands. Okay, at least some of you know what is Node MCU. So the difference between say something like a simple Arduino Uno and Node MCU is the fact that Node MCU has got, what is the additional feature that Node MCU has?
Wi-Fi.
Yes, Node MCU has got a Wi-Fi module built into it, and that is the reason why it is so popular. So in traditional the normal Arduino Uno, you do not have that option. You have to give wired connection, or you may have to add a Wi-Fi module separately to it. There is a new version of this which is called Arduino Uno Wi-Fi. I have a couple of those modules with me, so which have integrated Wi-Fi module built into them. But conventional Arduino Uno will not have it. So that is why people go for Node MCU type devices. And let's take the example of say Node MCU itself. You will find that it has got a microcontroller built into it. It has got GPIO pins. It has got, I think, one channel analog input. I don't remember exactly. So it has got very limited IO. It has got very limited inputs, analog read, and it runs on very low amount of power also. So the entire computing facilities that are required for dealing with say like a temperature sensor or a pressure sensor or something like that, whatever input is coming in can be provided by devices like Node MCU or Arduino Uno, right? So that is one part of the whole smart object. Okay, so what you have in case of Arduino, in case of Node MCU is that you have both the microcontroller or the processing unit and the communication system integrated onto one single board. Same thing happens with Raspberry Pi also. You have the processing and you have the Bluetooth or Wi-Fi module built into the board itself. So please remember, when I talk about the smart objects, it is not going to be a single unit itself. It's going to be a board. Usually it will be a board, right? So you will have a board with a microcontroller. You will have a board with on the side there will be power supply. On the side of it there will be some small antenna and so on. So it's basically going to be a board, not a one single IC. It will have multiple ICs put on the same board, enclosed in one single one, like say IP65 box or something, which will be safe to use in the field. So typically that's how you look at it. Okay, and for processing, as we have seen in the screen that I am sharing now, you require very limited amount of computing for the time being. But as more and more data needs to be performed, to be processed, you will need more complex uh, communication devices and more complex processing systems. So if you are say processing video signals or audio signals for your IoT application, you will require something like a Raspberry Pi at the minimum. But if you're only reading temperature, or if you're only reading the light intensity, or if you're only reading the presence or absence of a person in the room, then very simple Arduino Uno or Node MCU could do the work for you. Not a big deal. So based on the use case, you will have to pick up your microcontrollers. Okay. Can we go to the next slide? If you have any questions, please go ahead and ask.
Sir, no question.
So we'll go to the next slide. This is the sensors and actuators. Okay. So in this, what we have is, this is another part of the IoT node, which will consist of the sensors which you want to use to measure the physical parameter. So say you may have a IC which will be picking the temperature, LM65 maybe. You may have a LDR which will be detecting the light intensity, or you may have a hygrometer type IC or a digital compass, whatever you may have, all those will be mounted on one side, and they will be picking the physical, they will be interacting with the physical environment, they will be picking the readings from there and feeding it to the compute unit or the microcontroller unit. Okay, and the actuator will have some kind of output. So the microcontroller or the computer unit that you're seeing here, that will be kind of initiating some action by turning on or off the actuator, or turning on and off the something like, say, maybe a relay or something like that. So all those will be done by the actuator. Okay. So some small actions can be done. Like for example, if you want to say you have made a IoT node which will float on water. So if you want to make it float just below the surface, then you can uh, actuate a control valve or actuate a relay which will turn on the water flow into the sink inside, and then the node will sink partially within the water, or maybe bring it out and float on the surface exactly, and so on and so forth. So several things can be done. So small actuators can also be built into this, but it is not necessary that all IoT devices should have all of these units. Actuators are typically an option. I have not seen it as a compulsory unit. I don't find it as a compulsory unit in most of the IoT devices, because actuation is not something that is essential to functioning of an IoT system. There may be separate huge actuators sitting there, but all boards or all IoT nodes need not have actuating mechanisms into it. But the other units are fairly common. There will always be a computing unit, there will always be some kind of sensing, there will always be some kind of communication, and there will be power source. Actuators, though, I have not seen them as an essential unit in most of the IoT boards. Okay, so we'll go to the third one. The third case is that of a communication device. This is obviously compulsory because it is called Internet of Things, right? Internet. So you need to connect to the internet, or you need to connect to the cloud, or you need to connect to the other devices. So for that, some kind of communication is needed. So you will find a dedicated Wi-Fi module built into it, like your Node MCU. Or you may have a Bluetooth module which is built into the board, or you may have LoRa module which is add-on to the device, or you may have something like wired connections. You may have Ethernet or UART connection, or uh, RS485 connections, CAN communication. So all those things, any communication, wired or wireless, is usually required if you are developing an IoT node. In fact, this is something which is essential. Okay, I have not seen any IoT node which does not have some kind of communication module built into it. But they can't exist, no, because communication is a key aspect of it. So that is there, and we have already seen there are hundreds of communication protocols available which can be implemented. So based on that, you will have a different size of antenna, you will have different ways in which they are implemented, power requirements will be different, and so on and so forth. So that's how they are connected. The last unit that is important is the power supply. So we have discussed previously that you can have a wired or a wireless power supply to the system. It is not always necessary that IoT nodes should always be powered by batteries. You can have IoT nodes which are powered by mains power supply also. If you take the example of smart electricity meter, each smart electricity meter is a node in an IoT network, okay, which is run by the electricity board. So for that, you do not need to put a battery, because it's already an energy meter, right? Electricity power meter. So you can directly take it from the mains and supply it. On the other hand, if you have something like a weather monitoring station which is remote, which is located in the middle of a jungle, you do not have the luxury of having mains power supply there. So you will have to rely on things like solar, or maybe wind, or maybe battery alone, depending on circumstances, you may have to deal with. Battery is typically used when there is no main supply, and in addition to that, you will usually also be adding solar or wind or something like that to compensate for the depletion of charges over a period of time, right? So that's what happens. So that is the major idea or the major parts of your uh, thing in the Internet of Things system. Was this clear? If you have any issues or any questions, please go ahead and ask. This is rather self-explanatory, right? I don't think there will be major questions. But still, I'll give you 2 minutes in case you have some queries. No. Okay, so one small thing before we go to the next slide. It is not necessary that you buy IoT nodes from any manufacturer directly. You can build your own IoT nodes. As you can see from this diagram itself, you can integrate multiple modules and build your own IoT node. It's not a big problem. You can do that, but usually it is recommended that you buy ready-made nodes from suppliers. Robert Bosch makes this kind of nodes. You will have nodes which are made by Siemens. There are nodes which are made by Seed. So several uh, manufacturers make IoT nodes which are more reliable than what you do by hand, because we are not professionals. So if you are very good at soldering and very good at checking the reliability of devices, good. But if you are doing it as a hobby project or something where reliability is important, I will suggest that you buy ready-made nodes which are available. Okay, so that is one small suggestion. You can do it by yourself also, or otherwise also, but reliability is better if you buy from the manufacturers themselves. Okay, so there are two terms that I wanted to tell you about. So there is something called sensor networks, sensor actuator network, and there is something called wireless sensor networks. Okay, so SANET, this is not a very popular name or a common name that you will hear. This is actually an idea of a sensor and actuator network. So what happens is you have uh, sensors and actuators connected together, and the sensing happens, the actuation also happens, and there will always also be humans in the loop, kind of, who will be looking at the cloud and looking at what the data is being connected by the sensors, and if the actuation that is happening is okay or not. All those things are basically done with the help of sensors and kind of wireless sensor network and sensor actuator network. Just 1 second. Just give me a second. I wanted to play a video. I think the audio is not there. Just 1 second.
Safe, efficient energy production and distribution.
You can you hear the audio?
Yes, yes, sir.
Okay, okay.
Depends on well-maintained infrastructure, including pipes, tanks, vessels, and heat transfer equipment. One of the many threats producers face is metal loss and degradation, with its potential to halt production and create environmental and safety problems, including economic losses. Until now, inspecting for corrosion, erosion, and cracking was a slow manual process, fraught with safety risks, high cost, and poor data integrity. But Sensor Networks is changing that with a new breed of automated corrosion monitoring technology based on installed ultrasonic sensors. A technology capable of accurately measuring remaining wall thickness and calculating corrosion and erosion rates. A Sensor Networks installation is controlled locally or remotely using a tablet, laptop, or industrial computer. This control can be semi or fully automated using local or solar power, with data transmitted via wired network or wireless broadband. The computer communicates with a network of digital sensor interfaces, or DSIs, via RS-485 protocol, initially prompting the first DSI to gather ultrasonic thickness measurements from up to 16 connected transducers. The DSI sends an ultra-short analog pulse to the first connected transducer, where it is converted into high-frequency acoustic or ultrasonic energy. That energy travels through the subject material and reflects off the back wall. The signal from the reflection is converted by the transducer back into an RF electrical pulse and then digitized by the DSI. The sequence is repeated for the other transducers connected to the DSI. Once a DSI has successfully communicated measurements from all its transducers, the next DSI is prompted to do the same. For any given DSI, transducers may be arranged randomly or in a linear or area array, giving you the versatility to monitor unique geometries, such as pipe elbow extrados. In this manner, measurements are automatically gathered from a network of up to 32 DSIs, representing a maximum 512 individual transducers, all on a single multi-drop cable stretching as far as 1,000 feet, or alternately, over a wireless mesh network. Either way, the entire measurement cycle takes only a few minutes to complete. Results are presented locally and can be transmitted via a simple email or to a cloud-based data center for analysis against historical data, yielding an instantaneous, enterprise-wide understanding of asset condition and deterioration rates, with the ability to drill down to specific at-risk locations. Sensor Networks components are available intrinsically safe and are highly configurable to specific corrosion, erosion, and crack monitoring needs. Several transducer types are available, including single-element contact, dual-element, delay line for extremely high temperatures, and angle beam transmission for crack monitoring. For O&M supervisors, Sensor Networks represents a new way to improve safety, data integrity, and critical asset management while significantly lowering the costs, delays, and risks associated with manual data collection. Sensor Networks, delivering automated asset integrity monitoring to help energy producers maintain safe, productive, and regulatory compliant plant infrastructure.
Okay, I hope now you understand what do you mean by sensor networks. Is it clear? Do you have any queries?
Sir, why can't we connect the multiple transducers to a single processing unit, sir, instead of like bunching up transducers and connecting to multiple processing units?
No, what happens is that you cannot, the length of wires is one major challenge because of the fact that you have signal loss. Like, when the sensor reads some data and it needs to be transmitted, like usually from the sensor, the output that you're getting will be of the order of few millivolts or maybe at the most a few volts. And in an industrial scenario, the longer the wires you have, the more risk of electromagnetic interference comes in. So the best option will be to have short cable lengths, and then once it reaches some kind of a controller or something like that, you convert that into completely digital form, and once it is in digital form, the risk of corruption becomes less. So ideally, whenever you are making some kind of analog measurement, it is a good idea to have a smaller kind of length of wire to the processing unit. I don't know if that answers the question. EMI
Yes, sir.
is a major problem. Electromagnetic interference is a major issue. So you quickly convert it into digital as much as possible. So have a short run of cable, put it into microcontroller, and once it is digital, difficult to corrupt those things. So that's how it works. Any other questions? No questions. Okay. So now we will go to the idea of a wireless sensor network. Okay, we have seen what is a traditional wired sensor network. If you remember, this guy was talking about something called RS-485 communication system. So this is the typical industrial wired communication system. So you have a multi-drop cable. That means a single pair of cables will be running, and you can basically tap into those wires and connect multiple devices. Up to 512 devices can be connected in using RS-485. So that's the protocol's limitation, that you can connect only 512 devices at the best. Okay. So and one more thing was that what do you mean by multi-drop? The idea of multi-drop is I don't know if you have kind of set up your people usually set up those lights in Deepavali and all those things, that big rice lights, right? You have seen those, no? Like small lights will be there. There will be one long strip and there will be small lights all over the place. So how you connect them is using this same technique. So you just tap the live and the neutral, connect a small LED bulb there. Pick up the live and neutral, connect a small LED there. So and so on and so forth. So basically you are connecting so many of them in parallel. Same thing is happening with RS-485 also. Two wires will be running throughout the length, and you are basically tapping them to connect more and more devices. And each device will have its own device ID. So at the maximum 512 devices will be connected. And there will be one master and all others will be slaves. So the master will tell which sensor should respond. So those units that you are seeing, so each of those units will be assigned an ID number, and there will be one of them which will act as a master and say that, okay, this ID number 1 should now send the data, ID number 2 should now send the data, 3, 4, 5, 6. So sequentially, each of those nodes will be sending data back to the central server. That is why there will be no collision or there will be no congestion of traffic in those nodes. Otherwise, because it's just a two-wire communication, there is a big chance that there will be a lot of collision of packets if there is no control. So that is done with the help of a master-slave type system. It slows down the whole process. It's a very slow process. If you have more devices to reach the last device, it will take much longer. But this is one way in which you can have a very low cost setup. And when there is data kind of transmission is not very critical, time critical, this will work. Okay, so we'll go to the next one, wireless sensor network. Let's see.
Wireless sensor network. Toshiba's technology enables sensor networks to watch over people and society. Connecting together urban functions, a wireless sensor network allows nodes to communicate with and control one another. It can be used to monitor infrastructure such as bridges and tunnels. Power and network cables are unnecessary. Even places requiring long-term observation for detecting structural deterioration can be monitored simply by attaching a sensor. This maintenance-free system reliably collects sensor data across a wide area. Toshiba's technology will maximize social safety by connecting the increasingly complex urban functions of the future with high-reliability networks. Technology that maximizes social safety. Wireless sensor networks. The important factors in this technology are the formation of an autonomous mesh network and achievement of low power consumption. Without the use of special settings, each wireless sensor autonomously recognizes ambient conditions, adjusts the timing of communications, and forms a communication network with neighboring sensors. By adapting to various conditions, the wireless sensor network gathers sensor data reliably across a wide area in a bucket relay format. The network also minimizes standby power based on communication conditions, so that wireless communication can be maintained for long periods using batteries alone. Enabling sensor networks to watch over people and society. Imagine the future. Create the future.
Okay, so this is the idea behind a wireless sensor network. So if you see, one of the major things that they mentioned about was the idea that you can make wireless sensor networks uh, behave normally even if you do not have a direct connection to the cloud. The individual nodes have information which is hopping from one device to the other. That was what they were showing in the last stages. So you could have the messages which are jumping from one node to the other, and the nodes which are closer to the server will be integrating them all as the messages come along. And by jumping one after the other, it will be just going into the final server. So you do not actually need to have a direct connection to the cloud as such. So each individual node need not be connected to the cloud. But now, because the cloud connection has become very easy, you kind of bypass that problem. But in several cases, because power requirements may be very kind of stringent, so you kind of send a small burst of data to the next node, and the next node will collect the data from two nodes, transmit it to the next node. The next node will collect it from the four nodes, transmit to the next, and so on and so forth. So as you go along, the nodes which are closer to the server will collect more and more data and pass it on. That is the idea of a wireless sensor networks. So they can work independent of the cloud also. Just through local multi-hop communication, they should be able to work properly. That is one requirement of a wireless sensor network. Okay. And if you are interested in learning more about wireless sensor networks, please have a look at there is something called a MOTE, MOTE. Okay, MOTE is the wireless sensor network unit that people used to work with. So this is again pre-IoT uh, kind of era we are talking about. Okay, IoT wireless sensor networks have been in existence for quite some time. We even have an MTech program in remote sensing and wireless sensor networks with SEN. So these are all like before IoT became such widespread, and before the networking became so good, and before we have 4G, and before we had such reliable communication. So now you can think of wireless sensor networks as something which is uh, very specialized type of an IoT network. Okay. So if you have any questions on these two, please go ahead and ask before we move on to the next slide. Any questions?
No, sir.
Okay, so let's go to the next slide.
Why?
Next slide. Okay. Right. So this is the idea. So this is what I was talking about, modes. Okay. So typically wireless sensor network nodes, what we call as things or nodes in our terminology, are referred to as modes in wireless sensor network terminology. It's only the terminology wise difference, and you can see the diagram wise also there is very little slight difference between what you may call as the normal IoT node and that of a mode. Okay, so you can see the idea of developing a mode is all around minimizing the cost and minimizing the amount of computation that is required. So the idea is that you have to make modes as cheap as possible so that you can deploy them as widely as possible. So the overriding theme for a mode is low power consumption and low cost. Whatever compromises need to be made for that, they will make it. So that is the idea. On the other hand, the idea of a typical IoT node is to ensure that communication happens properly, the computation happens properly, and that the power supply is more reliable. So whenever you have a system which, whenever you need a system which is very reliable and you want to make it work properly for a very long period of time, IoT nodes are more preferred. But if you want to deploy cheap, low cost sensors over a wide area, so that at least 90% of them work or 80% of them work, and that should be good enough to give you the results, then you go for modes. Okay, so for example, you want to say check for the presence of infiltrators on the border, right? You want to uh, have some sensor mechanism which will detect the presence of intruders in the India Pakistan border. Our India Pakistan border is around about 1400 kilometers long. You can't have sensors every 1 kilometer or every half kilometer or every 500 or every 200 meters or something like that. So what you can do on the other hand is you can make millions of modes which can detect motion and spread them all over the border. At least 90-95% of them will work. The 5% which will fail will be somewhere spread around, and they will not affect the working much. So for the same cost, you will be able to cover much larger area, and you should be able to generate at least some basic understanding of what is happening. You may not be able to identify who is coming in, what kind of explosives and stuff he is carrying and stuff like that, but you will be able to detect motion. So if your requirements are low and you want to cover more geographical area, then a better option is to use modes. Otherwise, you go for typical IoT node. That is what you are seeing here. Minimizing energy usage. Memory also will be required, will be very, very low. Few tens of kilobytes. So tiny OS is the one which is used for programming those kind of devices. And you have low power wireless communication, which is typically mesh type communication. It's not connected to the communication will not be strong enough to connect it to the cloud. It will be like a multi-hop communication. So from one mode to the other, the information will jump and go. Right? And you will find that the data rate also will be very low. Power consumption also will be very low. So these are the major characteristics of a mode when compared to a typical IoT device. You can think of a mode as a extremely lean version of a typical IoT node. Very lean implementation. So you shave off all the excess, you keep the minimal amount of things that are needed. What results is a mode. Okay. Just give you some simple idea on how to set up a wireless sensor network. Meanwhile, do you have any queries on this? So far, what we have seen?
No, sir.
Okay. So I think I have around 7 minutes. I'll just try to show these videos, or maybe we will just do this in the next class. I'll stop with just 1 second. Somebody's in the lobby. Okay. Fine. So I think we have some time still. Anyway, so we'll just go ahead with this. So what can you see the screen?
Yes, sir. Yes, sir.
Yes. So what I will show you now is how to set up a basic idea of how to set up a typical wireless sensor network from an industrial system. A very short video. So we'll just go through that very quickly. Is the audio okay?
Yes.
Okay. So you can see this is how a typical IoT system will be working. You will have wireless sensors, and then there will be one system which will be integrating all the information which is coming in, and that will be fed to the typical PLC. PLC is programmable logic controller, which is a typical industrial uh, controller. Okay, you can think of it like an industry level controller which can kind of control industrial devices like motors and switches and so on. Okay, and HMI is your human machine interface, which is also referred to as GUI. You've heard of GUI, right? Graphical user interface. So in a industrial terminology, it is referred to as HMI. And Modbus is the communication protocol which is used for connecting these devices together. Okay, RS485 or Modbus is typically used. So let's see what happens. This is your wireless sensor node. So you can see there are multiple sensors available, and this is your wireless sensor node. So this kind of covers, this will cover the computation, communication, and the power supply part. Sensors are external because you may require multiple different types of sensors to be integrated. So you have pressure sensor, humidity sensor, whatever you want, you can just screw into this and it will become a sensor node for that particular physical parameter. So you can see the industry standard connectors are also available, which you have to use. So you can see they put a lot of emphasis on what kind of connectors you are using. So there are several industry standard connectors, and if time permits, I will suggest that you go through those also. Uh, you can start with a page on Wikipedia. So there are several types of industrial standard connectors, from the very basic like a BNC connector to more complicated type connectors which are required for specific type of applications. Okay, so be very careful when you are choosing devices. Say if you are integrating multiple devices from multiple vendors, please make sure that the interfaces and the connectors are matching. Otherwise, people get stuck here. And if the connectors are not matching, if you try to do mix and match, or if you put some converters, there could be signal loss and there could be issues with electromagnetic interference also. So it's always a good idea that you match the connectors before you purchase something. It is something very simple which people kind of miss in between, but it is a very essential part of the system integration process. You need to make sure that the connectors match. There are multiple different connector types, so be careful with that also. So you can see there is a battery module available. So whatever diagram we saw initially, all that is integrated into one this small box. Right, so we have almost everything that is needed. Sensor, processing unit, communication. This decal is just to help them understand what kind of sensor it is. So this is all going to be through software. I'll just skip all that. It's not essential. For each of the devices, it will be a separate kind of configuration mechanism. Assuming that you have connected all of this. You will be connecting all of this to your PLC, and the PLC will be able to pick up all these things, and HMI should read the readings and make it. Or you can connect it to the cloud. You can see this. If you look at this, you can directly connect to the IoT through the IoT gateway. You can go to the IoT platform, and from the once it is in the IoT platform, you can create your own visualization, or you can create your own controller, and then you can make it work. It's not a problem at all. Okay, so I think this should complete today's class. If you have any questions, quickly you can ask me. We are already out of time. Any questions? This is like a typical industrial wireless sensor network. Okay.
No, sir.
So does it make sense? I mean, like what we have seen so far, what is a sensor network, what is a wireless sensor network, and how individual units look like. So they do not look the same way that you find in your textbooks. They're slightly different. So they can form the size like a cylinder. They can be in the form of a flat Raspberry Pi kind of a board and so on. So don't go by the looks. They look different for different applications. Okay. Any questions?
No, sir.
No. Okay. Fine. If there are no further questions, I think we can break for now. These are very interesting things. If you want, just for your improving your general knowledge, at least just have a look at. I'll suggest for today, at least for today's class, I'll suggest that you have a look at what are the different types of connectors available. Okay. You may not even have heard of many of the connectors which are used in the industry. Right. So right from RJ45 onwards to BNC to there are several hundreds of connectors available. So if time permits, just go to Wikipedia and search. That should give you some good understanding of what type of connectors are available and how do they work. Okay. So thank you all for attending. We'll continue in the next class, and we'll continue with wireless sensor networks. Okay. So thank you all for attending. Bye.
Thank you, sir.